Welcome guys to another tutorial from Let's Make a Game Together. My name's Dave, and today we are going to be starting our new tutorial on 2D platformers. And to start, as promised, we're going to look at Super Mario Bros. 1. Now, why are we looking at this game first? And that's because we're trying to replicate this game. And I know that might seem like we're doing something that's a bit outdated, but there are many design decisions that were made in this game that really are just amazing for its time and even still today. Now, you notice this game, if you've ever played it, came out in 1985 and it has no tutorial. You're literally just chucked into the action and you're taught everything through intuition, which is some amazing things that everyone should bring into their games, in my opinion, because it helps people learn exactly what to do and why, and they feel smart because they worked it out themselves. Before we start, I just want to mention that I do have a Patreon, so if you do feel like supporting this channel and what we do here, you can check it out. It's links in the description. Every little cent counts. It's all appreciated. Thank you so much, guys, for anyone who is willing to donate to this channel. Okay, so let's get started. So first thing I want to do is check out the actual game. So if I just start the game here, you'll notice straight away that the character is on the left-hand side of the screen facing right. Now, if he tries to move left, straight away he's given this, he knows that he can't go any further. Just straight away, just shows you, okay, so I must go right. It's already taught the player that you move from the left-hand side of the screen to the right-hand side of the screen. And then it gives you the player this safe area to move around where the camera doesn't move or nothing, where he can test out the buttons. And on the original NES, it had only a few buttons. So the player would initially press A and go, oh, I can jump. Oh, cool, I can jump. That's pretty cool. And then as he moves along, he'd be creeping along, and then he'd see this guy and he'd be like, oh, what's this guy doing? And if you hadn't learned how to jump, it doesn't matter. Why it doesn't matter is because the gameplay he lost then was only about a few seconds. So he realizes, oh, that mushroom is bad, and then he comes along and he goes, okay, mushroom bad, I'm going to try and jump over the mushroom. So he jumps over the mushroom successfully. He sees these flashing things. He goes, maybe that jump command that I just learned might do something if I hit it. And he finds out that he gets a coin. And then he tries it on this one here, and then he gets another mushroom comes out. But this one he tries to avoid, and as he tries to avoid it, he runs into it. And it's no mistake that this was here designed so the player would bump his head, hit into the mushroom, and then he would grow big. And then he'd realize, oh, some mushrooms are good, and other mushroom-looking things are bad. Now, if he wanted to get up here, and he's just pressing the jump button, he notices that he can't. So this is something that we'll talk about, which is like extended jumps, double jumps, like jumping and things like that. In this Mario game, you can't double jump, but if you hold the A button, he jumps a little bit higher. And which also feels correct. If you're using the controller and you hold the A button down, your player will jump further, and that's what it feels like. You're pushing the player to jump further. You're holding it down. And then, of course, there's little obstacles along here. If you notice that the cloud texture and the bush texture are exactly the same, that was very intuitive just to save memory because the NES cartridge could only hold so much memory. And then you come to this spot here where you go, okay, I'm stuck between these two areas and I've got to jump. And then it does the same thing, but it throws two Goombas in the pit. And you realize, oh geez, how am I going to get across this? And so the player's slowly given new things, new challenges to handle, and he might end up jumping on one and realizing that, oh, I can crush one by jumping on its head. So what I'm trying to get at, guys, is, and we won't go any further, but what I'm trying to get at here, guys, is the game is implementing mechanics and showing the player mechanics as he progresses, without telling the player anything with text, without doing anything like that. The game shows the player what to do by just setting up scenarios where the player has to use their own brain, and that's going to be a big portion of our tutorial series. So, enough of that. Let's jump down this pit, die, and we'll jump into Unity. We are going to create a new game. I'm calling mine Super Platformer Bros. It's going to be 2D, and I've chosen the location where I'm going to store my project. Okay, so a couple of housekeeping things first. I'm just going to go File, Save Scene As, and I'm just going to call it, let's say, Prototype 1. You can call it whatever you want, it doesn't really matter at this stage, but at the start we're just going to be prototyping some ideas, and we're going to press save. Okay, so now we're in prototype 1, just double click to make sure, save the project, save project. Going to change the camera here, up here, from just down to 16 by 10. It's not super important, but just something for now, just to make sure we're all on the same page. And that should be it. Now, before we jump into creating any assets or anything like that, I've got a few things that I want to talk about. One is the game is going to look like crap for the first little part. They always do. All games, I'm sure you've heard me say it before, all games look like crap until you get further into development. Now, because I've made a few games, I've learned to just deal with this fact and try to imagine things within my head. But if you are a new developer and you can't stand it looking like crap with programmer art, you can get some placeholder art work here. The place is called opengameart.org, and I believe that a lot of the artwork in here is free, and it'll all work with the game that we're using. You just have to check to see if you can use it in commercial games, etc., etc. It's all on here, but opengameart.org. It's a really cool website, and you can get lots of really cool art, and yeah. But the reason why games, it's not just us indie developers who prototype with really crappy art. The idea is if you create a game with really crappy art and it's fun, then it's going to be really good with real art and real music and real effects and things like that. And if you don't believe me, this game here, The Legend of Zelda: Breath of the Wild, was prototyped like this. This is literally the prototype for The Legend of Zelda: Breath of the Wild. They wanted to make sure that it was fun to burn bushes and to roll logs into the rivers and things like that. This is literally how they prototyped it. By the way, this is an amazing talk. You can check it out on YouTube. The Legend of Zelda: Breath of the Wild GDC talk. Amazing talk. Anyway, back into Unity. I have created some assets for us to follow along if you don't mind using crappy art, and it took me about 5 seconds, so we're just going to import those assets now. The link will be in the description for the assets, so I'm just going to open the assets now. So I'm going to locate the art in Finder or in my computer, and I'm just going to drag that into Unity. And here we go, we have our artwork. If I click on it, we can see that it is a sprite 2D. It's single. If these settings are different, your settings are different to mine, it might be because you didn't press 2D when we first started the new project, but you can just change the settings to be like this. And we want to change it to be multiple, and we want to say pixels per unit. Let's just keep it at 100, and let's click on Sprite Editor, click Apply, and we're just going to slice this automatically, slice, apply, and then you've got, all of a sudden we've got all the different assets. It's really good like that. And exit that. Okay, so you can also choose the filter mode to be point or bilinear. I think we'll leave it at point for now, just so it doesn't blur any of the edges and makes it a bit easier. So you see we've got the ground textures here. We got there's a white texture. We got an amazing block, a question mark block, two little legs, and a little destroyed block. You can see that my patience was running out by the end. So first thing we're going to do is inside of our scene view here, we're going to click and drag this block here, and we're going to, you know what, I think that might be a bit small. I'm going to click back on prototype here, and I'm going to change the pixels per unit to, let's say, 50. That's pretty good. So change that to pixels per unit to 50 by clicking on there, and yeah, you get it. Okay, so we got this here, and we can just click and drag this out just so it fits. And this is another reason why crappy art is good for prototyping. Everything is all good. And we're just going to go click on the prototype art _1, the thing that we just brought in the ground, and we're going to click add component. Wait for my beat up MacBook Pro to hurry up, and then we're going to type in box collider 2D, and you'll see on there that it actually creates a small, you probably can't see actually, but it creates a small box collider around the actual object, and this is why physics will work for us now. So next thing I want to do is drag in our player, There he is. Now he's a bit big, so we're just going to make him 0.5 and 0.5. I think that's good enough for now. Doesn't matter. Once again, guys, this is up to you. We can rename it as well. So let's call this player, and let's call our original ground that we put in ground. Okay, cool. So in our scene, we've got the main camera, which is what makes our gameplay, the ground, and the player. So add some physics is quite easy. We can just get the player, add a rigid, well, let's actually add a collider first. Let's just add a box collider for simplicity's sake. If you look, you'll see that it doesn't quite match the character, but that's fine. This is just for prototyping. This is just for testing it out. We're not even going to worry about the legs at this stage. We're just going to leave it as is. Next thing we're going to do is we're going to add another component called a rigid body 2D. And we're going to make collision detection continuous, start awake, and constraints, we're just going to freeze the rotation because we don't want him to rotate, and we're going to leave all the rest of this. Okay, so when we press play now, the character should move down and collide with our surface. So ta-da, we have a game with physics, and that was pretty simple, pretty straightforward. Our character falls down. But to actually do anything with our character, to move him around, we need code, obviously. So that's the next thing that we'll be jumping into. But before we do that, let's just save it. File, save scene, save project. We want to make sure that we're always doing that. And let's just straight away open up some code. So we want to create a new C# script, and we're going to call this player underscore move underscore prototype, prot, whatever you want to call it. But basically we're going to, so how I'm going to set this out at start, we're going to create a quick and simple dirty way of doing things, and then we're going to actually iterate on that in the future to make the physics better, because we can use custom inbuilt physics inside Unity and it will be okay, but it won't be, it may not give us all the control that we want. So basically, yeah, we're going to start out really simple, get a character moving. If this is your first game, you'll be pretty stoked, and then we're going to go into some more complex stuff. So let's open up the player move script. Okay, to start out here, we're going to go really simple to start off with. So let's just create a public variable, public int player speed. We'll need a public bool. And we're going to call this facing right. So the reason we have this is we just have just a public bool which equals to true or false, that just says, is the player facing left or right? And if he's facing right, it'll equal true. If he's facing left, it'll equal false. It's pretty simple, but it just helps us determine which way the player is facing. And we're just going to have another public float called, let's make this an int actually, int. And we'll make this player jump power. Cool. So let's assign these variables. So let's assign the player speed to 10. Let's assign this to true. And let's assign the integer to let's go really high, 1250. I plan on using some 1250 equals 1250. Okay, cool. So now we don't, I don't think we'll need start at this stage. I'm going to zoom out a little bit. It's making me a little bit insane having the text that high. Okay, then we're going to go to update, and we're going to create a new method inside update. So update runs every single second, so every single frame that the game is running. So we want our player to be able to move every single frame that the game is running. So we're going to create a new method called player move. Oops, it autofilled there. Player move. And down here, we're going to create that method void player move. Okay. So inside player move, we're going to have a few sections. We're going to have the controls. We're going to have the animation. We're going to have the direction. Actually, we'll call this player direction. And we're going to have the physics. Cool, and we're going to create another method called jump. So void jump. Jumping code. If you're new to coding, my only advice is just to keep watching tutorials, just keep learning, don't get frustrated, you'll eventually get there. This would have been way over my head when I first started, but how I found that I got a lot better when I just kept watching tutorials and things like that. I really loved Quill18. If you want to check out his tutorials are really, really good. Okay, inside controls, we are going to, actually, we need to create a new variable first. So let's go to up here and go public float move x. Like I said, this is a quick and dirty way of doing it, but this will get us up and running really quickly. So we're going to just write move x, which is this variable that we just assigned up here, which is short for movement on the x plane, is going to equal input dot get axis horizontal. So we type it out just like that. It should all be good. And we're not going to worry about animations just yet. We're going to say inside player direction, we're going to say if move x is less than 0.0 f, and facing right, which is this boolean that we created up here, equals false, then we're going to flip player. So flip player. Now that won't load for you because we haven't created that method. Let's create that down here. Void flip player. Cool, so now that should be spelled exactly the same, look exactly the same as that. So basically saying if our movex variable is less than 0.0f and we're facing right, and we're not facing right, then flip player. And then we're going to have another, we're going to have an else if here. Move x is greater than 0.0f, sorry, greater than 0.0f, and facing right equals true. Then we're going to flip player. Cool. So it's basically saying like that, saying if we're facing one way and then we move the other way, it's going to flip player. If we're facing the other way and we want to face the other way, it's going to flip player. Don't worry, it'll all make sense in a little bit of time. And then the last part is physics, and we're just going to literally control the character the quickest, dirtiest way. Game object dot get component. So we're accessing a component. I just want to quickly explain this a little bit. When we say game object of get component, we're accessing something on the component that the script is attached to. So if the script that we're creating is attached to the player game object, it's going to access one of these components: the rigid body, the box collider, or the sprite renderer, providing that we have them. So we're saying game object dot get component rigid body 2D and we're going to just access the velocity. That's going to equal a new vector 2, which is equal to move x times player speed, which is this variable up here, comma, game object dot get component rigid body 2D. I'm going to zoom out a little bit. Hopefully you guys can see that. Dot velocity dot y. Close bracket, and there we go, done. And make sure you do a semicolon at the end, and that's the total line of code that it gets the player to move left and right. So we should probably test this out before we go any further. So if you go back to Unity, and we go to our player, we can click Add Component, type in player, and our script should be there, or you can just click and drag it on, whichever one you want. And we got you can see we've got our variables here, our player jump power, our move x, and our player speed, and we can just press play. And the player moves left and right. Hooray! He won't be able to jump yet, he's not going to flip yet because we haven't put in that code, but he moves left and right. That is fantastic, we're off to a good start. So let's go back into MonoDevelop, and let's go to the player, should we do player jump or flip first? I think we'll do flip first. So inside of flipping the player, we're just going to say literally facing right equals not facing right. So this symbol here, the exclamation mark, just basically means not true. So it's just a way of saying facing right does not equal facing right. If you're new to programming, that'll confuse the hell out of you, but that's okay. Vector 2, local scale. Sorry, vector 2. We're creating a new vector 2 variable called local scale, and we're going to equal that to game object dot transform dot local scale. Then we are going to access that local scale variable, and we're going to say local scale dot x times equals -1, and then we're going to say transform dot local scale equals local scale. Okay, a handful I know. So we're basically saying, well, if you're facing right, and we call the flip play method, we don't want to be facing right anymore, so it assigns this to not facing right, this variable up here, the public bool. Then we're creating a new variable that's just called local scale, which is the scale of the player. So if we go back into Unity, this is the scale up here. It's going to change this from a 0.05 to a negative 0.05. What you see here is flipped. Take that negative away, it doesn't flip. It's really, really simple. And then we're just timesing and equaling that by -1, and we're changing the transform of this game object to this local scale, which is the variable here. Pretty simple. Let's test it out. Let's press play. Okay, it works, but not really. For me anyway, when I press right, he faces the other way. When I press left, he's facing the other way. That's not what we want. So let's just fix that now. Okay, so a way to fix that quite easily is just here, our facing right variable. Let's just untick it. So we're not facing right when we first start, even though we are. I know, don't worry, we'll get there. We'll chip away. Let's just play, and yep, he moves left and right, faces a different direction. Happy days, yay! Now I've noticed here, like some of our scripts here our variables here don't need to be public; they can be private. especially facing right and move X. So let's just quickly change them. So let's change the move X here to private and facing right to private. It's just so whatever we change anything in this code, it will also change it inside of Unity. But if you were to come and change some of the public variables here, it would still listen to the inspector before it listened to anything else. If we click back here, should see that they go away. Yep, they've gone away. Cool. Cool. Okay, so the next thing we want to do is just add some jump code. Pretty simple. We're just going to, like I said, do a very ghetto way of doing it. Get component. Oh man, what's going on in Unity? Come on. I should say monodevelop. Get component rigid body 2D dot add force vector 2 dot up times, you guessed it, player jump power. Okay, so this is just saying once again we're accessing the rigid body 2D, which is once again the rigid body 2D here, and we're accessing a function or a method that's associated with rigid body 2D, which is just to add force, and we're going to add force in the direction of vector2.up, and we're going to times that that force of the direction. We're going to times that force by player jump power, which is associated here, which we can assign in the inspector. Cool. So now let's move over to Unity. Let's see if it works. Press play. Fantastic. Play moves left and right. Still doesn't jump. Let's check why. Well, obviously it's quite simple. We never call this jump method. How does it know when it needs to jump? So if we go into the player move script here, we go under controls, and we just type if input.get button down jump, then we're gonna, guess what? Gonna call jump. Cool. So this will work now. I need to put another bracket there. Okay, cool. So this is basically saying if the input.get button down. So if you press the jump button, we're going to jump. And the jump button by default is the space key. And you can check out all this stuff inside file or edit. Input. You can change all of this stuff inside input. There you go. Jump. Space. But we're not going to do that. So let's just press play. And our player is jumping. He's jumping really, really high. Let's give the player the rigid body. You can mess around here with the mass, the linear drag. We'll just set it to maybe 1. A gravity scale, let's set that to 10. See how that goes. Cool. So our player now jumps. Fantastic. And you'll see that the camera doesn't move, obviously. We need to code that in still. He can jump forever, which isn't good. But at least, and he's got no animations, got no sound, and the game is pretty boring. But at least, hey, we got a character that's moving and jumping pretty easily. Under 20 minutes, we've got a character rocking and rolling. This is really awesome. Well, I think for this, I'll leave it there. Stay tuned for the next episode, guys, and thanks to everyone who supported me on Patreon. I really appreciate it. Really appreciate it, guys. It's really awesome. And I'll see you guys next time.